Okay, tangent. Tangent graph is totally different than the other ones. Now, I want to talk about what tangent just generally looks like first. Generally, the tangent graph looks like this. And its complete cycle is done in a much quicker time than the other ones. Now, do you remember me saying before that tangent was y over x? I don't know if you ever stopped to think about this. If tangent of the angle is y over x, we also said sine was y. Sine of the angle is y. And cosine of the angle is x. Do you get that tangent is really, if y is really sine, then tangent is really sine over cosine. Tangent is really sine over cosine. If it's really y over x and y is really sine and cosine is really x, then it's really sine over cosine. Why is that cool? Do you know that if the tangent button on your calculator broke, you could do tangent just by finding sine of the angle and then finding cosine of the angle and then dividing them? So tangent is just taking sine, taking cosine, dividing them. All right, so what does that mean? That means if I have a graph that had sine on it and cosine on it, and I can make that really quick and easy. Here's sine, and then I'll make cosine in green. Cosine goes down and then comes back up again like that. Then I can just take sine, the red one, and divide by cosine, the green one, and I can find tangent. So how does that work? Well, if I start right here at 0, the red one's at 0, and that's sine. The red one's sine. And the green one is at 1, and that's cosine. If it's sine over cosine, it's like 0 divided by 1. What's 0 divided by 1? That's 0. That's why it's 0. See? It hits right there. Okay? How about when will this thing fail? Whenever cosine, if tangent is sine over cosine, whenever cosine is what? The whole thing crashes. When cosine is 0. Do you get if there's 0 on the bottom, the whole thing's going to crash? So if cosine is 0, which is right there, and there, when cosine is 0, this thing's going to crash. This spot right here where it crashes, that creates that asymptote right there. All right, I'm just trying to explain. Instead of just telling you, here's where sine and cosine, or instead of just saying, here's what tangent is, I wanted to show you it actually gets created by dividing sine over cosine. Do you have to reconstruct all of that for the test? Nope. You just have to graph tangent. But if you forgot what tangent's graph even looked like, you could do it by looking at the sine graph, looking at the cosine graph, and just dividing them. Okay. So other things you'd need to know. Tell me, what else isn't, like, there's no numbering on this at all. What numbers would you want to know? Come on, think about what are the important spots. Okay, where is 2 pi? Good question. It's way over there. Totally not even on the graph. Yes? The asymptotes, those are important. They're at pi over 2 and negative pi over 2. Why? Because those are the spots where cosine is 0. And if tangent is really sine over cosine, if cosine ever hits 0, and it does, these are the places cosine hits 0. It hits at pi over 2, and it also hits at negative pi over 2. There must be asymptotes there. Okay. Now, do you get that there's a number 1 in here somewhere, but it doesn't really matter much? Because this thing rises forever. Okay, and there's a negative 1 somewhere on this axis, but it doesn't really matter much where it is. There aren't really super important points on tangent that I need you to memorize. It goes through 0, 0. It's all about the asymptotes. The asymptotes being at negative pi over 2 and pi over 2. Guess what the most common mistake answer is on what is the period of tangent? Most common mistake answer. Yes? Pi over 2 is one of the most common mistake answers because people go, see, it's pi over 2. It finishes at pi over 2. But do you get it also goes this way, pi over 2? So what does it take to do a complete cycle? Half a pi plus another half a pi makes pi. The other common mistake is some people think that everything's period is always 2 pi. Nope. That was for sine and cosine, and therefore also for secant and cosecant. But these last two, tangent and cotangent, their period is pi. And this is important. How long does it take to finish? Half a pi plus another half a pi this way makes 1 pi is its period. So that formula that used to always be 2 pi over b doesn't work anymore, but it's simple. Change it to what? For tangent, what do you change it to? Pi over b. The new formula for tangent, equation for the period is pi over b. All right, so what does that mean? Let's say that we had to graph tangent of, let's make it just something fairly simple, tangent of 2x. I already showed you what tangent would have looked like. Well, it's going to look a lot alike. It's just, remember how we just changed the numbers? There, I did tangent. As long as I can label it right, I'm good. Normal is pi over 2 and negative pi over 2. So how do I change it? I use that formula and figure out its new period is not 2 pi over b, it's pi over b for tangent, and b is 2. So its period should be pi over 2. Now some people look at this graph and go, oh, well the period already is pi over 2. See, it's like a pot of pi over 2 right there. If the period's supposed to be pi over 2, these numbers have to get, what, bigger or smaller? Smaller. This has to become pi over 4, and this has to become negative pi over 4. That way, when I take that pi over 4 and that pi over 4, I get 2 pi over 4 total. 2 pi over 4 is the same thing as pi over 2, isn't it? Takes a little more thinking to renumber these. But do you get my picture didn't change? Still has asymptotes on both sides. The swoop of this stayed the same. No big deal. All right, here's another one that would be fairly easy. Sketch me tangent first. Make a new one, sketch me tangent. And then, after you got tangent graphed, with a dotted line, make me negative tangent. Put a negative out front, see what happens. So I'm making my blue one be regular tangent, my green one being negative tangent. Well, here's my blue one, regular tangent. Hopefully you did that right. This is pi over 2 and negative pi over 2. Always label it. Then, my green one is to flip it. Do you get this as another one of those weird functions? Where if I flip it up, down, or I flip it left, right, it's going to end up looking the same. What did I ask for by putting the negative out front? Is that a vertical or a horizontal? The vertical. Vertical on the outside, right? That's a vertical reflection. If I reflect it up, down, this way, then it's going to look like this. You might have used a dotted line, or you might have changed colors, whatever, but there we go. Do you get that would be the exact same thing as if I reflected it this way? All right. Okay, that's tangent. Now, what's the last graph I haven't taught you? Cotangent. You would think cotangent would be as simple as just like flipping tangent around and like this green one here. It's not. not the same as that. Okay, let's look at what cotangent really is then. If tangent of x was sine over cosine, then since cotangent is the flippin' sister, cotangent would be what over what? Cosine over sine. So now where are the asymptotes going to come in? They're going to come in whenever sine is 0. Sine is 0 in different places than cosine was 0. So I got to go graph sine quick. Everybody, please make me a quick sine graph. By now you should be experts at this. Make me a quick sine graph. And this is pi over 2, pi, 3 pi over 2, and pi over 2. When you're done with it, turn it my way. I want to see it. Some of you are just trying to watch me, and it's not going to work. Good. Thank you. Yep, label it, though, because you'll need those labels. Label it, though. I like the asymptotes. That's a good touch. You don't need the asymptotes yet, but label it. Good. Good. It's labeled. Yep. You even have the y-axis labeled, which is awesome. Yep. 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 Still waiting for a few of you. Hurry up, please. Yep. 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 You have too many loops. Too many loops. Check hers. Just keep it turned and take a look at hers. Hers is perfect. She's really close to you. All right. Okay, good. Now, why do you think I had you graph sine? Yeah, because if sine is ever 0, what's going to happen with cotangent? Undefined. It'll have an asymptote there. So when does sine hit 0? It hits here and here and here. And those spots have asymptotes here and here and here. All right. Now cotangent looks a lot like tangent, but it's not something that just like secant or cosecant where it rides on the back of the parent thing. I can't just use that. That's not going to work. And I could show you again that it's cosine over sine. I guess I could show you that really quick. Here's the sine graph. And the cosine graph I'll be doing black here. Start here at the halfway mark. It's down there. And it ends there. It goes like that. Okay. And if it's really cosine over sine, then right here, this is the cosine graph. And the red one's the sine graph. If it's cosine divided by sine, do you get at this very moment, it'll be 1 divided by 0. That's why it won't work, because 1 divided by 0 doesn't work. That's why there's an asymptote there. Okay? At this very moment, right in between the two green asymptote lines we drew, this spot right here, sine is 1 and cosine is 0. And remember, it's the black one divided by the red one. So it's 0 divided by 1. Is 0 divided by 1 okay? Yeah, and it's 0. All right. Do I really expect you to recreate all of this? No. But I'm trying to show you that's how I get this spot that I'm going to graph next for cotangent. It's because I did right here 1 or 0 divided by 1 to get me that spot. All right, and now, do you remember how tangent was always rising? That was like tangent. Cotangent is the flip of that. So it is always falling. There's your cotangent graph. One thing good about cotangent is you can tell its period really easy. It doesn't deceive you. Do you get that its period is pi? And you can tell easily because it goes from 0 to pi. It completes a full cycle. Do you get if I start another one, I'm doing, that's 2 full periods of cotangent? It's the exact repeat of the previous one. If it's an exact repeat, then you started the cycle over again. So 1 pi, or 1 period, is from here to here. That's 1 period. So I actually graphed 2 periods of cotangent on that graph. Okay, quick recap. Tangent goes up from left to right. Cotangent, whoa. Cotangent. Asymptotes are here and here. Notice the asymptotes are different. And instead of rising it goes from left to right. It's going to hit that middle spot, but it's going to hit it by falling as it goes from left to right. That's cotangent. Okay? Period of this thing is 1 pi, so this makes this pi over 2 and negative pi over 2. Period of this is 1 pi, and so it goes from 0 to pi. There we go. There's cotangent versus tangent. I know that's your first, sight of them, but they're not that rough. Now we have homework on it, which will help you to set it in your mind, practice it enough so that you understand it. And they'll have a few stretches in there, but don't stress. It's not super hard. So this one we just did there was cotangent. Oh, could you label the middle spot on cotangent? It's halfway between 0 and pi, right? It's got to be pi over 2. Okay, so then let's say that I was going to ask you to do what is y equals, instead of just cotangent, that's what we just did. What if I changed it to 3 times the cotangent? We didn't even have any labels on the xy axis. But I'd want to label something that was something that used to be 1 and negative 1. Now I need to change to 3 and negative 3. That's all you'd have to do. Okay, then what if there's no 3 there? What if instead there's a 3 on the inside? And I don't need that. That can be 1 and negative 1 again. And, oh yeah, period on this is different. Period is, what is it again? Pi over b. What is the b in this case? 3. So the period is pi over 3. This one's, again, easier to change. You don't have to think it through so much. It used to be pi. Now it's not pi anymore. It's what? Pi over 3. What did you really multiply that by? 1/3. And therefore you multiply this by 1/3. And that'll make that into pi over 6. Okay, now let's see if you really caught all of that. Let's just start our homework. Instead of me making up ones for you to practice, let's do practice off the homework. I think there's enough problems there. Plenty enough. So let's find it. It's 4.5.2. I'll pause while I pull that. So here we go. This is another one of those where they just want you to graph tangent. And then they're going to ask you a bunch of questions about tangent. That'll help you think it through. Okay? Same idea down here. We're going to graph cotangent, and then they'll ask you a bunch of questions about cotangent. All right. Then we start actually trying to graph tangent by stretching it. That's the one where you're going to use period. You might want to write this in the margin for yourself. Period is pi over b. So in this case, pi over 3. And if the whole period on tangent is pi over 3, you got to understand that that means this whole thing is pi over 3. So each part, this part, would be half of pi over 3, and therefore, what? What's half of pi over 3? Pi over 6. All right, good. All right. This one has a b term of 1/2. If it's pi over b, then it's pi over 1/2 in this case. Well, instead of dividing by 1/2, you could times it by 2. So this becomes period is now 2 pi, which is what the normal period is for the other functions. This, for this guy, though, it means he's finishing in 2 pi, which is he's going to finish twice as slow. Well, here's tangent. I personally like to run mine on the every two marks deal. And normal tangent would be pi over 2 to negative pi over 2. And here's normal tangent. There we go. How curvy that is isn't that big of a deal to me. It just has to always be rising as you go from left to right. That's normal tangent. Now I got to renumber it based on this. And that's we did this and that. And if our period is 2 pi, a really common mistake people make is they think, oh, I'm going to make this 2 pi then. No. If the whole thing is supposed to be 2 pi, how much should this number be right here then? If the whole thing's 2 pi, how far should this be right here? Pi. And that way you can have another pi going this way. And that adds up to 2 pi total. Okay. So, let's see if there's any we can skip here. I'd say you could probably skip number 10. And 11 and 12 are good. I mean, you need to know how to do that, so can't really skip those. I never skip review problems, so we'll skip 10 and I'll skip something else. Let's skip 7. 7 and 10. Okay. I don't think this should be too bad. I'll start number 1 here with you. If tangent is the one that's centered on the x, or on the y and x axis, on the origin, I guess you'd say. There's tangent, done, that quick. Then I just have to, notice it only asked me to graph it over that interval. I shouldn't keep making them, even though I could. In theory, I could make it another one in here, and another one in here. That's 3 periods of it. I only wanted to graph 1 period between negative pi over 2 and pi over 2. Okay. For what values of x does tangent of x equal 0? For what values of x? So they want these kind of numbers. This spot, or this spot. Where is tangent equal to 0? 0. If x equals 0. Part C, for what values of x does tangent have vertical asymptotes? Oh, so there's the x values of the asymptotes. These are easy questions. For what values of x does cosine equal 0? Why are they talking about cosine? Because remember, tangent is sine over cosine, and they want to know if you understand tangent of x is sine x over cosine x, that cosine being 0 is what creates those asymptotes. And what's the y-intercept? Where does it touch the y-axis? That's an easy question. All right, I hope you're getting the idea, and that's all I have for you for today.